Hey, welcome back to ICP. Today we're going to be talking about force, and it's another review here. I'm really excited about today. Let's see what we can learn. Okay, let's review our first two laws again. Um, Newton's first law. Well, what's the other name of it? The other name of Newton's first law is law of inertia. Example. Let's talk about seat belts here with this. Seat belts. Seat belts are an example of Newton's first law because uh, what do seatbelts do? All right, seatbelts help fight the law of inertia. Um, when a car stops, all right, when a car stops, I'm just going to draw the seat here. The person without a seatbelt, their inertia would keep wanting to go forward. So how does a seatbelt work here? Well, a seatbelt then just does the opposite because the natural law is to go forward. The seatbelt is what fights that inertia so that you don't go through the windshield. Right? Newton's second law. Well, our equation again is we say it's easy to think of if you just write it out. A force causes a mass to accelerate. All right, and basically it's going to be in the same direction. And what that means then is, let's say I have a car, and here's my car. It's a jalopy. You like some of my drawings here? There's my car, and it hits this tree. Well, the tree applies a force in that direction. The mass is the car. The acceleration is in the opposite direction the car was going. Kind of looks like McDonald's car there. But what we're finding out here then is because the tree applies a force. We know that it applies a force because there was an acceleration on the car, and it was in the opposite direction it was going. How do we know that? Because the car decelerated, and it would cause it would need, if the car is changing speed, then it's accelerating, and in this case it's a negative acceleration because it's going down. Right, the car would be going down, so it's a negative acceleration. That means in this drawing we would say the force is a negative force, simply because we'd say this direction is positive and the direction over here to the left is negative, for no other reason. Okay, here's our equations. I keep trying to flash those up there to you. Next thing I want to talk about here is there's three forces, basic three natural forces. We've talked about one of these so far, and that's gravity. All right, gravity is a force of attraction between two objects. Any two objects. It doesn't have to just be planets. You can have a penny and a nickel. They are objects, so there is a force of attraction between them. Now, why can't you feel it? Because they're very small. All right, and that's why there's very little attraction between the two. Likewise, you have Earth, and you have a person standing on Earth. Well, why do we feel the force of attraction? Why do we feel gravity? Because Earth is very, very large. All right, but I want you to know that gravity is still the weakest of the three. All right, still the weakest of the three. The next one I want to talk about is the electrical force. Now, I'm not going to go into a lot of detail with it because we're going to discover or talk about electricity, but there is a force, electrical force, a positive and a negative charge. There is an attraction force. They will be attracted to each other, and it is stronger than gravity, but it's not the strongest force out there. The strongest force is called the strong force. And this right here is in an atom. If you think about in the nucleus of an atom, you've got all these protons in the nucleus. And naturally, if we just think about the electrical force, all of these protons are going to want to go away from each other. Because the electrical force, they're all positive, they're going to repel each other. Well, the strong force, and we'll talk about this, or you may have talked about this in chemistry, is provided by the neutrons in here. The neutrons provide such a strong force that they're able to overcome the electrical force and keep the nucleus together. And because they're able to hold it together, they must be providing a force that is stronger than the electrical force, and that's why we call it the strong force. Okay, earlier when we talked about projectile motion, we had the Earth, and I had this object that was circulating around here. And we said this was a delicate combination of uh, velocity or speed and dropping. And why would it be dropping? Because of gravity. So it's this, both of these things, speed and gravity. It has to go fast enough so that as it drops, it isn't able to get back to the Earth. By the time it keeps dropping, but stays in orbit. All right, we said as it goes fast enough, it'll stay in orbit. If it goes too fast, it'll take off. All right, it'll keep going farther and farther, and it'll get too far away. Um, so this object, this is called a centripetal force. All right, this centripetal force is what pulls the object in the middle. Now, well, it should actually be FC force, and it's a centripetal force. This is pulling the object in. Now, how do we know there's a force pulling it in? Because this object has mass. If it's a satellite, it has mass, and it's changing direction. This is key. All right, it's constantly changing direction, so it must be accelerating. Well, if you have a mass that is accelerating, there's a force, because remember Newton's second law? A force causes a mass to accelerate. In this case, it's accelerating because it's changing direction. Well, hey, the only other thing I have for you guys then today is this writing prompt. I want you to go through this. I'm not going to read it out to you, but you need to write a short essay over this writing prompt. Um, Make sure you read the whole thing. Situation, this is what's happening in Nebraska. This is who you have to write it to. Right? And then you're going to be scored on these three contents right here. Your ideas and content, do you accomplish the task? All right. Organization. Do you have an introduction, a body, and conclusion paragraphs? Language conventions, grammar. Although I am a physics teacher, I can tell really bad grammar. Thing I do want to point out to you, because this is what students a lot of times skip, is you need to write it basing it on, and I'm not really worried about all three. Why don't we just do the two that we've really talked about? Using Newton's two laws of motion as a guide. Write a letter to convince State Representative Mr. Sean Kimball to pass a required seatbelt law. Be sure to support your position with convincing arguments and specific details. Well, hey, it's been great talking to you today. I'll catch you on the flip side.